Today we are going to learn about linear combination as a method for solving systems of equations. So linear combination is basically you're just adding two equations together to get one variable to cancel out. This is also known as or referred to as the elimination method, and it really is a much quicker way to solve systems of equations than graphing or using the substitution method. And the graphing method has its flaws where if you try to graph and it doesn't cross at exactly an intersecting point, it's hard to know what the real solution is. And substitution method can just be kind of tedious with replacing part of the equation in. So let's take a look at how linear combination works. So linear combination, we're taking a look at two equations and we're really trying to find terms that are going to cancel out if we were to add. So you can actually think of this as one large addition problem. And I see this 2x minus 2x. If I were to add, like vertically add the two equations, 2x plus a minus 2x, since they're opposites, those two equal 0. And I have y, or 1y, plus a negative 7y. So think of it as 1 plus a negative 7. That would equal a negative 6y. And then 5 plus 13 is 18. So negative 6y equals 18. I already have my y term by itself. There's just one step left for solving to find y. I can divide now by a negative 6 on both sides, and I find y to equal a negative 3. So my y coordinate is a negative 3. We still have to solve to figure out what our x coordinate is going to be. So we want to take this y value of negative 3 and plug it back into our equation. So 2x plus y equals 5. And you could have chosen the other equation too. I just chose this one because I'm not working with negatives then. The second equation has a lot of negatives, so I chose the first one. So 2x plus a negative 3 equals 5. I want to get my 2x term by itself. So the opposite of adding a negative 3 would be to just add a positive 3 on both sides. These two cancel out, and we are left with 2x equals 8. And dividing by 2 on both sides to get x by itself. 2 divided by 2, we have x. 8 divided by 2, we have 4. So our solution to this systems of equations is an ordered pair. It's the solution 4, negative 3. So remember, solutions are ordered pairs. And if we check our answer, so plugging these coordinates back in, 2 times 4 is 8, plus a negative 3, so 8 plus a negative 3 is 5. So that one checked out. Our second one, if we fill it actually in, so a negative 2x minus 7y equals 13. So this is our check. I'm going to plug in a 4 for x, so negative 2 times 4 minus 7 times a negative 3 equals 13. Now we have to make sure we follow order of operations. Negative 2 times 4, that's a minus 8. And then think of this as a negative 7 times negative 3. Negative 7 times negative 3 is a positive 21. And we want to check to see if that equals 13. And negative 8 plus 21, since this is a negative, we're going to subtract to find out how many there are, because one's negative and one is positive. So 21 minus 8, that does equal a positive 13. So this one also checked out. So our solution is 4, negative 3. Always list your solutions as an ordered pair. So let's look at another example. When you're working with linear combination, you're always trying to find the terms that cancel each other out, or where their coefficient is the same. So when I look at this one, it's a minus x and a plus x. These are the ones that when I add are going to cancel out. because over here, a 3 and a 2, they're not the same number. So I can add these two equations because they're opposites. So a negative x plus x, they cancel each other out. That one equals 0. 3 plus 2 is 5y. And then 15 plus 10 is 25. So now thinking 5 times something equals 25. If I divide by 5 to get y by itself, I would have y equals 5. So my y coordinate of this solution is 5. Now taking the same value and plugging it back into either of the equations, I'm going to choose the second equation just because it's all positive numbers again. So x plus 2y equals 10. Plugging 5 in for y, we have x plus 2 times 5 equaling 10. X plus 10 equals 10. And I want x by itself, so I'm going to subtract off this 10. And I end up with x equaling 0. So the solution is an ordered pair again. The solution is 0, 5. My x coordinate, 0, and my y coordinate, 5. So the solution to this systems of equations is 0, 5. And again, you should always check your answer. So 0 plus 2 times 5, so 10. 0 plus 10 equals 10. That one checked out. Trying this one, a negative x, so a negative 0, that's still just 0. And then my y coordinate is 5. 3 times 5 does equal 15. So this one does check out. One last example. Looking at this equation, we have 4x plus 5y equals negative 5, and x plus 5y equals 10. I don't see any opposites. Remember, in order for them to cancel out, they need to have opposite signs. But what I do see is this one is a 5y, and this one is also a 5y. So I'm going to work to try to get these two to cancel out. But since they're not opposites, instead of adding, you're really subtracting. You can think of it as subtracting each of those terms. When you're setting it up, I would recommend that you set it up so that you subtract each term. So in order to do that, change it for each term to show that you're subtracting. Otherwise, you'll make a mistake with negatives. So 4x minus x, 5y minus 5y, and a negative 5 minus 10. So show that you're subtracting. You can also think of it as changing the sign of each term. So now 4x minus x, think of this as a 1x. 4x minus 1x, we have 3x. 5y minus 5y is 0. And then a negative 5 minus 10, watch the negatives. Negative 5 minus 10, you want to add the opposite. So it's actually a negative 5 plus a negative 10 to get negative 15. So negative 5 minus 10 is a negative 15. That leaves our equation as 3x equals a negative 15. And divide by 3 so that our x is by itself. You end up with x equaling negative 15 divided by 3 is a negative 5. So there's our x coordinate of the solution. I'm going to plug this negative 5 in for x into one of our original equations. So again, use your original equation. Our original equation was x plus 5y equals 10. And you can use either equation. I just chose this one because my x was by itself. So when I plug it in, it's fewer steps. So negative 5 plus 5y equals 10. I'm going to add 5 so that it cancels out on the left. And if I add 5 on one side, make sure you add 5 on the other. And you're left with 5y equals 15. And dividing by 5, I can see that y is equal to 3. So this would be the solution as an ordered pair. Again, you don't have two solutions. It's one solution written as an ordered pair. So -5 is my x-coordinate, 3 is my y-coordinate. So the solution, this is the point at which those two lines cross at -5, 3. And again, always go back and double check your answer. If I were to plug these in, 4 times a -5 for my x value, I get a -20, plus 5 times 3 is 15. -20 plus 15, that does equal -5, and that one checks out. And this other one we already kind of checked out here, but if you plug it in, -5, so our -5 plus 15, because 5 times 3, so -5 plus 15 is equal to 10, and that one did check out as well. So the solution to this systems of equations is -5, 3.